to my channel. Let's solve some more Leetcode problems today. I'm Leo. So today's problem is pretty medium or easy. It's called wasn't gates. So basically we're given an n by n grid, rooms initialized with the three possible values. -1 stands for a wall or an obstacle here. 0 is a gate, and infinity is an empty room, which is here. So we were asked to fill each empty room with the distance to its nearest gate. If it's impossible to reach a gate, it should be filled with infinity. So we do nothing. Okay? What do we do here? So this is like a typical BFS traversal. If we start from the gate, the nearest grids would be marked as 1, and then the neighbor of the ones is marked into 2. All right, so it's pretty obvious. Yeah, let's do it. So in m equals to rooms.length, and if rooms is null or n is 0, that means we don't have anything. We can just return. Just be reminded this is a void function, so we should just return. Okay, so next int n is rooms 0 dot length. Okay. If we have a gate, we put it into our queue. Okay, so we can initialize our queue, integer array, new linked list, and for int I equals to 0, I is less than n, for int j equals to 0, j is less than n. If rooms ij equals to 0, which is our gate, we put it into our queue. Okay, so we will not only have the coordinate of it, but also the distance from it as a variable in there. Okay, so while q doesn't equal to is not empty, we can record the size of it, or we can just do it as it is, whatever you can do. So I'll just do a typical layer by layer BFS traversal. So I'm going to record the int size is equal to q.size for int d equals to 0, d is less than size, d plus plus. Integer array cur is q.pull, and integer x is cur 0, integer y is cur 1, and integer distance is cur 2. Okay, so for all of its neighbors, this one is pulled out, and we have it as 0. Then we go to the neighbors of it. So for the neighbors, it's going to be new integer matrix x plus 1 y, x minus 1 y, x y plus 1, x y minus 1. Okay, so for all of its neighbors, na x is going to be na 0, and na y is going to be na 1. Okay, let's do some sanity check. If na x is less than 0, or na x is larger than or equal to m, or na y is less than 0, or na y is larger than or equal to n, or if it's not an empty room. Okay, so rooms na x, na y doesn't equal to integer dot max value. Okay, if that's the case, we're going to continue. We'll just skip it. Okay. Next, if this one has been reached by our BFS algorithm, we will mark it as the current distance plus 1. Okay, so rooms nay x nay y equals to distance plus 1. Then we add it to the queue. Nay x nay y and the distance plus 1 to the next level. Okay, so that should give us the right answer. Okay, that's the right answer. And now let's analyze the time complexity and the space complexity. We have to traverse through all the grids in this grid. So it should be Mn. And the space we used is a BFS traversal, right? So for BFS, I think we are also having a like m by n, because in the worst case we have multiple gates that needs to be expanded at the same time. So in the worst case it's m by n. It's all of the nodes in this grid. Okay, let's submit it. Yeah, that passes. Okay, and thanks for watching. I'll see you in our next video.